Hello everyone, this is my Physics 1 project where I will be rating different shows and movies based on how realistic they are through a physics perspective. The scene that I first have is from the show What If, where Peter Parker is pulling a subway train with his classic webs with his own bare hands. The question that I have is, can a human produce enough force to pull an entire subway train? The physics law violated is Newton's second law of motion, and the hypothesis that I've made is if a normal human is pulling a train with normal human anatomy and capabilities, then they wouldn't have enough force to pull the train over a certain amount of distance. What's given is the subway car mass that I have found, which is 38,600 kilograms, and average pulling force of humans, which we will be using as reference, which is 400 newtons. Then the next step, we would need to find the acceleration, but before that, we would need to find the velocity. And as the distance isn't clearly stated, we would need to find that as well. In the scene, it can be seen that Peter travels 4 different railway planks, and average distance between each railway plank is 0.45 meters. Multiply that by 4, and we will have our distance, and then we will have our velocity, then our acceleration. With our mass and acceleration, we would be able to find our force, and based on the calculation done, it can be seen that a train with a mass of 38,600 kilograms would require an amount of 1,085.65 newtons of force. One average human being is known to have an average of only 400 newtons of pulling force, therefore deeming the scene physically inaccurate. Therefore, I will rate this scene as a PGP-13. Though it is a rather far from real physics, it may still be fun and explained since the character is a superhero and might possess superhuman strength. However, parental guidance is still not needed to not compare it with real-life physics. The next scene I have is from My Hero Academia in Season 4, with this huge character called Fat Gum and a random adult male experiencing a perfectly inelastic collision, however with zero final velocity. The question that I have is, can a human collision end up with zero final velocity? The law violated is conservation of momentum. And the hypothesis that I've made is if 2 normal humans collide, then there would be inevitably a positive or negative final velocity and would not result in zero final velocity. The given is the Fat Gum's velocity as he stays not moving throughout the final and initial velocity, and his mass with 130 kilograms. And for the random human, I found a average running speed of 2.65 meters per second and an average adult mass of 90 kilograms. And with that, we will have our given. And what I'm trying to find is the final velocity in order to find if their final velocity is indeed zero or not. And through the calculation, it can be seen that the calculation suggests a perfect analytic collision between both Fat Gum and the man would result with a final velocity that is 1.06 meter per second. In this scene, both of them remained in a zero velocity after the collision, deeming the scene to be physically inaccurate again. In conclusion, I rate the scene as a PGP-13, as though it is not exactly accurate, the scene is not far off from reality and the calculation. The next scene I have is a scene from Lock and Key in Season 1, where a key is melting a steel door. The question that I have is a steel prison door. And the question that I have is, can a room temperature steel key melt off a prison steel door? And the physics law violated is Black principle, or the heat and thermal outcome. And the hypothesis that I've made is if a steel door melts when it comes in contact with a steel key, then the key would need a very significant temperature, which is far from possible. And these are the given, the room temperature that I will be using for the steel door, average key weight of 10 grams, the prison door weight of 40 kilograms, and the specific heat of steel, steel's boiling point, as well as the latent heat of fusion. What I'm trying to find is the initial temperature of the key, where it would need how many temperatures is needed in order to melt the steel door. So as done by my calculation, as shown in the calculation, it is clearly inaccurate since the numbers are way off and illogical. In order for the key to melt the steel door, it needs to have a temperature of millions of degrees Celsius, which in itself already does not make sense, as in that temperature, that key would have melted and perhaps evaporated in the first place. Based on those facts alone, this scene can be considered as wildly inaccurate, and I will be giving it a rating of XP just based on the ridiculousness of the numbers. The last scene that I have is from My Hero Academia in Season 1, where a student throws a ball 705.3 meters. My question is, can a human throw a ball for 705.3 meters away? And the physics law violated is linear motion and Newton's second law of motion. The hypothesis that I've made is if a ball is thrown 705.3 meters, then it would require a large amount of force, which is most likely unable to be achieved by normal human beings. Then this is the calculation where I found the distance and the time by the screen time of the show, and it can be seen from the velocity. So in conclusion, the linear motion and kinematics seems to be accurate. However, when other laws are applied, such as Newton's second law of motion, it is obvious that no normal human can exert enough force in order to throw a ball of a distance of 705.3 meters. In the end, I'm rating this scene as an RP, as even though it is a superhero show, the numbers are still way off and it can easily be identified by any age that it isn't realistic and doesn't follow the laws of physics. That's it for my product of Physics 1. Thank you for listening.